Hello everyone, Dataninja here and welcome back to the channel. Today we are tackling a common pain point in the Python world, data validation. If you have ever dealt with messy untyped data or spent hours writing boilerplate validation code, then you are in the right place, because today we are diving deep into Pydantic, a library that will revolutionize how you handle data and validation in Python code. But what is Pydantic anyway? If you go to the website, they state in a single sentence: Pydantic is the most widely used data validation library for Python. If we scroll down, they give us a couple of sentences why we should use Pydantic. It says it has a great support of type hints, a seamless integration with your IDE and static analysis tools. It's really fast. Pydantic core validation logic is written in Rust. As a result, Pydantic is among the fastest data validation libraries in Python. And also Pydantic supports emitting JSON schema, allowing for easy integration with other tools. It also supports strict and lax mode. Pydantic can run either strict mode, where data is not converted, or lax mode, where Pydantic tries to coerce data to the correct type where appropriate. Pydantic supports validation of many standard library types, including Dataclass and typedict. It's very customizable, allows custom validators and serializers to alter how data is processed in many powerful ways. Around 8,000 packages on PyPy use Pydantic, including massively popular libraries like FastAPI, Hugging Face, Django, Ninja, SQL Model, and many more. What is most important for me, Pydantic is downloaded over 600 million times per month, and it is used by fund companies and 20 of the 25 largest companies on Nasdaq. So what is the big problem we're trying to solve? Python, as much we love it, it is dynamically typed. While it offers incredible flexibility, it also means without explicit checks, you can easily pass the wrong type of data to your functions or classes, leading to unexpected errors, especially in larger applications. Imagine you are building an e-commerce application. You have an order and product class. Without Pydantic, your init methods might look something like this. This one and this one. You see, for every single argument, we have to check if it's the type is the correct one, what we expect, and if not, we raise a type error. But anyway, why it is a problem? It works. You see, if I create two products, you see it also checks the type, because 3 is not an integer. I got this error message, ID must be an integer, but if I correct it, so it is just works as fine. As you can see, we are writing a lot of repetitive error-prone boilerplate just to ensure our data types are correct. And what if we want to convert these objects to JSON? Not so straightforward, right? You will typically need to write a custom toDict or toJSON method. This is where Pydantic swoops in like a superhero. Pydantic allows you to define data schemas using standard Python type hints, and it automatically validates your data at runtime. It is fast, efficient, and makes your code much cleaner and more robust. So let's refactor our product class using Pydantic. Notice how clean and readable it becomes. First, we have to import the base model from Pydantic. We have to extend the base model, and the ID name and price, we just defined it like there would be a data class. And if I just instantiate the product, it checks everything. And if I try to pass ID as a string, it also works, because right now we are in a lax mode. But if I try to add price as a string, we get an error stating input should be a valid number, price. Unable to pass string as a number. What if we want to validate an email? For that, we have to import email str, and for order, we just state that the customer email has to be an email string. And if you execute this code, and you get an error that Python cannot find email string, no worries, we can fix it very fast. We just go to the Pydantic website and search for email str. And in the very first line, they state you have to install email validator. As you see here, in the first lines, I installed a couple of things for our demo purposes. Pydantic email validator, Pydantic settings, which we will cover later, and Jupyter, which allows me to run this demo as a Jupyter notebook. Alright, so for that, if I execute this, that just works fine. And if I instantiate an order like this, that's okay. But if I make a mistake and I pass a string which is definitely not an email, I'm getting an error. Customer email value is not a valid email address. So you see how easy it is? Let's say you want to dump it as a JSON. You just call model dump JSON and it is just out. And what if you don't like how it looks like? You just type ident 2, for example, and it will print out for you a really nice formatted JSON. All right, let's say we want something much stricter on the name of the product. For example, we want to allow all the lower and capital letters, numbers, dash, and a space. So for that, the field method provides us a very easy way to go. We can supply a pattern, a regular expression, which will do the trick. If I execute this, and if I add something which is not included, for example, the exclamation mark is not allowed in this regular expression. If I execute it, I get an error, string should match the pattern, blah, 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 and the laptop exclamation mark doesn't. So if I remove the exclamation mark, it just works like charm. Pydantic also allows us out-of-the-box nested model validation. Let's say we have the product, we have the order, and the order can have products, which is a list of products. If I execute this, and you see the name field still couldn't contain exclamation mark or something like that, if I add this one and execute it, I will get an error, product 0 name, string should match the pattern. So if I change it back and execute it, you see the order and the corresponding data which we assigned to it, they are both get validated. Also, we have a really easy way to create computed fields. What a computed field is anyway. For that, we have to use a property field, and the total price, how we're going to calculate, we just return sum of all the product prices for product in self-products. Okay, and as you see, we have the product data and order data. I'm constructing this dictionary just to be able to use this notation to create an order. And if I execute it, you see the first product price is 1,200, second one is 25.5. So the total price should be 1,225.50, and it works just like this. Also, what if we want something more strict, or we need something much more specific? For example, for the name of the product, we want only names allowed which contains a space. So for that, we have to import the field validator. It has to be a class method, and this method is very simple. If space is not in the name, we just raise a value error. And let's see how it goes. Right now it has a space, and if I execute it, that's fine. But if I remove the space, it throws me an arrow stating the name. Product name must contain a space. So one of the other cool features which I really like Pydantic models can be filled from JSON directly. So imagine your API received the data from an external API and you have something which you can convert directly to an order. And for that, there is a model validate JSON method. We pass the JSON data, and actually after that we are able to dump the JSON. Let's see how it works. So it's perfect to work with any kind of JSON that we receive from APIs. As I mentioned in the beginning, Pydantic supports strict mode. And what does it mean? Instead of lax mode, when it tries to convert types to the appropriate ones, with strict mode, it just takes the value as it is. For example, if I have this strict product with strict int and strict float, if I want to pass a string, it throws an error, said the ID input should be a valid integer. And if I change it back, it just works like charm. Before Pydantic settings, I always used python.env to parse .env files, but with this, it becomes so easy, I think I will never go back for that. So, you see, I have this env file, database URL, API key, and debug mode, and workers. And if I go back, this line configures the settings. It says the env file should be .env, and extra ignore means if it finds any other settings which is not listed here, that should be ignored. So if I execute it here, you see I have this database URL, the API key, debug mode, and workers. And how default works, for example, if I go back and if I uncomment it, because workers is not found in the configuration file, if I execute it again, the workers falls back to 1, which was the default value. Now, question I often get is, how does Pydantic compare to Python built-in data classes? Both are great for defining data structures, but they serve slightly different purposes. Type hinting. Both Pydantic and Dataclasses leverage Python type hints for defining fields. So that's a type. Validation. This is where Pydantic shines. Dataclasses offer no inherent runtime validation beyond basic type checking. Pydantic, on the other hand, provides a powerful automatic validation, including custom validators, regular expressions, nested model validation. So what about serialization and deserialization? Pydantic offers built-in, easy-to-use methods for converting models to and from JSON, dictionaries, and other formats. Dataclasses require manual serialization logic. And the last one, Dataclasses are part of Python standards library. Pydantic is a third-party library you need to install manually. For simple data structures where you don't need validation and serialization, Dataclasses are just perfectly fine choice. But for robust data handling, API development, or anywhere data integrity is critical, Pydantic is the clear winner. And there you have it, guys. Pydantic is an incredibly powerful and versatile library that dramatically simplifies data validation, serialization, and configuration management in Python. It helps you write a cleaner, more robust, and less error-prone code, ultimately saving you a ton of development time and headaches. If you are working with data, APIs, or just want to make your Python applications more reliable, Pydantic is an absolutely must-have in your toolkit. If you found this video helpful, make sure you hit that like button, subscribe to Dataninja XYZ for more Python and data magic, and let me know in the comments below how you are using Pydantic in your project. Thanks for watching, and see you in the next one.